Welcome to EDU World Space.
So you have this curve that is described by x is equal to natural logarithm of 2y plus 1. So it is easier to see this. Well, x is a function of y, so if we flip the axis as we do usually, we have this function and also more like that for x equals to 0. We're gonna have well, for y equals to 0, we're gonna have so 0 plus 1, so natural logarithm of 1 is 0, so it's gonna have the point 0 0, and then we have this curve for y between 0 and 1. So this curve is like a natural logarithm curve that displaced uh, so at by minus 1 half should be like over there minus 1 half, so the curve is gonna look something like that. And so when to compute uh, the area of, well, what happens if we rotate about the x-axis, so we will obtain like this curved cone, something like this, if we rotate about the x-axis. But so the way to compute this here, since here this the x-axis as our y-axis was usually placed, so the way to compute that would be the integral from 0 up to 1 of well, of s dy, but this s is equal to the length of the differential, well, this the differential of length of the curve, that is 1 plus f prime squared, where with this curve, with this function being f of y, so that our f prime, the derivative of that f prime is equal to the derivative of this is 1 over 2y plus 1, and then by the inner derivative times 2, so that if we squared, we have f prime squared is equal to 4 squared over 2 plus 2y plus 1 squared. Um, so so that um, also here my bad. So here the x for computing the would be y, because well we have to rotate about x. This here is y, so this is the area of this of rotating about s about x, which well it is this integral, the integral from 0 up to 1 y times the square root of 1 plus this term 4 over 2y plus 1 squared, and then dy. And if we rotate about x about the over the y-axis, it would be, so here the only difference would be that here we have f of y, that is, well, and this is 2 pi times that. So for this rotating about y, we would obtain something like this curve, this shape, like a vessel, something like this. Um, so this one has area. This one has area 2 pi, the integral from 0 up to 1 of f of y times that 1 plus f prime dy derivative of f prime squared. So this integral is equal to 2 pi times integral from 0 to 1 of natural logarithm of 2y plus 1 times the square root of 1 plus 4 over 2y plus 1 squared dy. And all these numbers, if you pull out your favorite calculator, this number is approximately 5.653, and this one over here is 4.2583. So this is the area about rotating of the surface obtained by rotating about rotation about the x-axis. The x-axis is this one, so it is this shape, and then rotating about y, we will have this area. So this one is area by rotating this curve rotation about the y-axis. Is that?